Peter, thanks. Thanks, thanks, thanks. Um,
Hi, Smalis. Are you the one hosting?
yes, I am the one hosting.
Okay. Let me see. I'm gonna make you co-host so that you can share your screen.
Okay, thanks.
Sweet.
Sorted.
Sorted. Yeah.
Yes. Yeah. Uh, yes. Can you guys see my screen? Um, it's gonna be hard for me to confirm the responses. Um,
Yes, we can see your screen, Smile.
okay. Um, Thank you. Uh, okay, we'll start in a few minutes. Just make sure everyone connects on the count. Um, so just an extra 2 minutes maybe. There's also a YouTube link. Should be forwarded very soon. All right. Is everyone getting connected on the crowd? You can talk, Bonga. Bonga, you can talk. I'm not sure if you're aware you raised your hand. I hate that this thing doesn't want. Bonga. I don't know why Bonga is his hand up, but I guess it's for the plot. Um, okay. All right. I think if we are somewhere around here, there's also a YouTube link if you are having problems with what's this? Okay, got it. If you're having problems with your what's that? If you're having problems with your Zoom, you can use the YouTube link instead, so that we can actually start. Um, for Amo, can you please make sure you check in the chats for me, and then you'll raise a hand if there's anything I have to check over there. Okay, guys, I'm going to start. I'm going to just start. Hello everyone. This is Manga. To the ones at Cape Town as well, this is Manga. So I think, yeah, I think for the guys at JHP, most of you would say that we already had a workshop about TDD, but it wasn't exactly centralized, and I think not everyone actually came. So this one was actually hosted from Performance Straight. So yeah, it's also a very neat presentation that we have for you. I hope everyone is good. I hope y'all are having a great day. And yeah, so we are going to be talking about TDD, which is one of, I think one of the best things that I think probably would have happened in tech, right? Um, TDD, as you know, as test-driven development, is a way that you can actually define tests to test if your program is acting as it's supposed to be acting, essentially if it's returning what you expected it to return, right? This, by the way, stems strongly from you actually making proper pseudocode for your stuff. So when you pseudocode, you normally get to find the expectations as in the end result of what you're doing. So from there, you can actually write tests going forward, right? But essentially, there's another very good topic under TDD, which is the red green refactor. This is one of the things we're going to be talking about today. And guys, please, if there's any audio problems or anything else, please make sure I know, right? Sure. So here's the outline of the workshop. It will be the introductions about the workshop, and then we're going to go into intro to 2DD, and then Ngabenta will be joining me to do the demo, and then you're going to have one exercise that we're going to do together on the what's this on the call, and then the second after that exercise we're going to be talking about testing techniques, and then I think the exercise two would be the strength calculator, essentially. That's where we are also going to give it to you guys to do it yourselves. And then afterwards, it's going to be just further reading, right? Before we begin, interaction rules, I think I've specified already to most of you guys that you have to be at your desks, not in any of the brown boxes. Even at Cape Town, I think Duncan has that sorted. The workshop setup, I think you guys are familiar with that again. Also, honor the time for the exercises. Please don't play around during the time of exercises. Do your work so that we can finish as early as possible. I think time has already left us a bit. Right. Workshop interaction. Stay on mute unless if you need to talk. Do not use the chat to interact with each other and the presenters. Do not, sorry. Do use the chat to interact with each other and the presenters. Use a raise hand. I think Bonga did it by mistake before he started. But use the raise hand functionality on Zoom to get our attention so that I can know that there's something that I have to answer or anything like that. You can raise hand, right? I don't think I should have that feature here, but you guys should have the feature for raising the hand, right? And then practice interaction. Confirm that you are set up for the workshop by raising your hand in Zoom. If you do not raise your hand, we will assume that you are not set up for the workshop. But I don't think this is exactly necessary for now. The mentors on the floor, please make sure that everyone is well connected, right? If you are not connected, please make sure you call one of the mentors on the floor to help you out with your PC. Thanks. So what exactly is TDD? It as test-driven development again. TDD is a set of programming practices whereby we write another program to test our program. The test program consists of lots of small functions that test every bit of functionality of the main program. We use TDD to gradually evolve a program whilst ensuring that it is functioning as expected. So on the last part, when it says we use TDD to gradually evolve a program whilst ensuring that it is functioning as expected. So essentially, if you write tests and then you write code that makes the test pass, afterwards you maybe want to refactor your code to make it look neater or add more comments and all those other stuff. So when you do that, we're gonna continuously still use testing to make sure that with your new features or your new code, you don't break the tests, right? So it makes sure that even on your refactoring phase, your refactors are actually correct, right? I'm just gonna flip this. Let me just put it on silent, sorry. Sure. Yeah. So why is TDD important? Number one, it creates a safety net when we change code. As I said, when you change your code, just to make sure that you're not breaking anything, you can use the test to keep on referring if the functionality is not broken. It also gives us confidence that our programs work as expected. So if you know the expectations of your program and the tests are saying this is proper, then you get some extra confidence from that. And then it is a technique that helps us evolve a design in small steps and encourages better design. So you will see with testing, let's say, for example, you have 5 testing functions. With those 5 testing functions, you will incrementally grow your program in its correctness, right? Until at least you get to the last step of that, right? It also encourages us to write just the right amount of code to solve a problem. I'm a victim of this because at some point I remember I once did a very cool mastermind program. It had colors and all, but when it came to testing, they asked me if I could test this, and then I essentially could not test it, of which was, it was a breakage in terms of how you actually should be developing software, right? So essentially, it should be testable, but also it encourages us to just write the right amount. So I didn't have to come up with the colors and everything. Once I have the functionality correct, then everything inside of that is correct. If I need anything else, then I can add on top of that. As I said, if you have anything else, it will give you the confidence to do that, because when you change the code, you will have something that will tell you if something else breaks. It also encourages collaboration in teams. So this is a more, I would say, a bit of a more advanced part. So essentially, when you continue with testing and going forward, you will see that it allows you guys to actually split tasks very well. So if someone wants to make a specific test pass, they would be working on that, and then the other person could be working on something separate, which is essentially a different test, right? So what is the TDD process? This is what I was talking about initially. So red, the first thing that we have to do when we actually do TDD, test-driven development, is you have to write the tests first. I know you guys still get excited and still write your code first, but what you're supposed to do essentially first is to write the tests. Because as I said, the reason why I said pseudocode is also a big player in this whole thing is because when you pseudocode, you get an idea of your expectations, and from your expectations, you can write tests, right? So when you write those tests, you will be expecting certain functions and all those other things. Because they're initially unimplemented, they will be failing. So in the red stage of your testing phase, you will be writing tests that fail, right? And then on the green one, you're going to make the tests pass just by writing enough code, right? So what do we mean by this is essentially just making sure that you can meet the criteria of the tests that you've written. If all the test cases pass from there, then you have went past the green stage of the process. And then the last part would be the refactor part. This is where you can actually improve the code while ensuring that the tests do not fail. As we said in the last slide, how do I go back again? As we said in the last slide, it will be giving you this. Also, it will be giving you the confidence to make sure that your programs work as expected, despite the changes that you are making, essentially, right? So the safety net will allow you to have some refactoring confidence. I'd like to actually match these two things and say it actually gives you refactoring confidence, right? So that's the part of refactor. So it's going to allow you to improve the code while ensuring that the tests do not fail, right? So if you feel like your function was too long, maybe it could be broken down into other pieces, you could try to do that. But then the tests will be there every step of the way to make sure that you're not breaking functionality, right? Um, example of a test program, which is what you guys have seen already, but I'm just going to go through it. So in Python, we have modules. I'm sure you guys know this already. The module that we use for testing is unit test. I know you guys did CS50, and essentially on CS50, of course, you use PyTest, which is a different one, but they all have their weights, right? You have to pip install PyTest. Unit test comes with Python, right? So it's much better to use unit test because it's out the box, right? It works in multiple environments, essentially. So let's say, for example, you have a method or a function, sorry, which is called increment, and your increment function takes n, which is a number. So let's say you have a number like 2 and you want to increment it. You would call the increment function and then pass in n here, which would be your 2. And then what this is going to return is going to be n plus 1, which would then be 3, right? So we know exactly what our function is supposed to do. It's supposed to take in a number and return that number plus 1, right? And then when you make a test class, yeah, I think most of you are kind of comfortable with classes I've seen on the floor. But even if you're not comfortable with classes, so there is a specific syntax to making the class. So when you make a class, you have to start with this as a prefix. So you have to start with test, and then you would go afterwards and just name it what you feel like is good enough for that test. In this case, it was named test incrementer. And then with that method, essentially, you're going to passing unit test.test case inside of the parenthesis for it, so that it knows that it is a testing class, right? So unit test will deal with everything afterwards for you. So you don't have to stress about those parts. And then you have to then create your test methods, right? So a test method is where you actually can test specific parts of your program. For example, this one tests if it actually does increase by 1, and then the self just refers to the class itself, right? So you don't have to also stress about that, but just know you always have to have a self here. And then this is your test method. And the reason why this one is a method and this one is a function is a method is something that belongs to a class, and a function is something that's just on a single page, I would say a single page program, essentially, right? So if it doesn't belong to a class, most of the time it will be a function. But if it belongs to a class, then it is a method, right? And then also when you write your test methods, there's also a syntax. You have to prefix it. I would say at within code, we prefix it with test underscore. Right. Even when you set up your tests inside of VS Code, it's going to be the very same thing. It's going to ask you, how did you actually define your methods? In what pattern are we looking for these tests? Right. So essentially what you're supposed to have there for that is test underscore, and then afterwards define what part of the program you're testing. So if this was a more complex program, so let's say, for example, this is just increased by 1. Let's say maybe I also wanted to test if it actually increases by 1 for negative numbers. Let's say maybe by the correctness of the program, maybe if I added a negative number, it returned it positive but incremented. So I'd want to make sure it doesn't break in that way. So I would have a test that says test increases by 1 negative number, right? And also do not be afraid to make these test method names as long as possible, right? As long as they're as descriptive as possible, we don't have a problem with that, right? And then the last part that you can use to actually do your comparisons and check if your function is actually working as expected, you're going to use the self.asset equal. So remember the class we gave it this, right? So when you give this class this, is it essentially inherits from the unit test framework, and then when it does that, it's going to have all of these methods inside of it, right? So essentially, when it has all of these methods, you can actually call them by saying self, which refers to the class itself, which also kind of sounds, like that. And then you're going to just say asset equal. So the asset equal will come from the unit test framework. And then when you say asset equal, the most important part, guys, is what you put this side is actual, and then what you put on the next side is going to be what you're expecting, right? So if I'm calling the method with increment 1, and then my n is 1 in this case, I'm expecting that this method is supposed to return a 2 in response, right? So this would be your actual, this would be your this would be your actual, which is what's coming from the function, and then this would be your expected value, right? And then you will see when you go on, continue exploring with this, that you can actually add a comma again and add a description for why the test case is failing. So this can be pretty helpful for when your tests are failing. You can actually tell the person that oh, oops, it did not actually increment by one, right? When I passed in this and that, right? So essentially it helps you actually um, be able to actually determine very well where the error is, right? So it's also much more readable, right? And then the last part of you doing the tests, I think half the time they actually do run, but that's if you they actually do run without this part, but that's if you are actually using VS Code with the beaker on itself. It will actually allow you to run the test case, the test classes, right? But essentially for you to actually make sure that when you run the command from the command line. As you can see, step 6 says make the test runnable from the command line. When you run it from the command line, essentially what that's gonna do is if you pass in this, if name is equals to main, you're going to call unit test.main. What this is going to allow you to do is it's going to allow you to actually run the tests from the command line, right? So this is one of the more important stuff, but you will see when going forward that maybe sometimes the beaker doesn't work. Maybe you want to be able to actually test from your terminal. So it's much better to always have that method. Actually, always have that method there, right? Never leave it out, right? So that's the example of a test program. And I'd like to take a pause and ask if there are any questions for this. Are there any questions, Amo?
No, there are no questions on Zoom.
Okay. All right. If anyone would like to ask a question, they can raise a hand. Okay. Right. We can move on, I guess. Separating code from tests. I think this is something that you guys have seen already. So for you to have a clean and modular interface where you are coding, essentially, uh, most of the time you'll find that there's a folder that's created where you actually put the tests. This is if you have a lot of files in your main, in your root folder, and then you want to actually separate them from the actual tests. Because if you just put tests and then the actual files there, it doesn't become clean and modular. So if you have that folder, you just have to also, like, I know this looks a bit shocking. So what this actually does is it tells Python that this is a Python module. So if you have a file where you're going to put in, for example, test incrementer.py, so essentially a directory, right? But I'm going to like demo this a bit, right? So if you have a directory that's going to have something like test incrementer.py, so inside of that directory, you'll have to have um, this file. This actually just tells Python that that is a Python module, right? This is just so your code is modular and clean, right? And then in your root folder, you can actually have your actual tests, your actual files, your program files that you are going to be working with, right? So the first one, as they are saying, is the program that is being tested. This one is the test code. And this one is also needed by unit test to make the tests discoverable, right? So as I said, if inside of the folder where you put this, you don't have init.py, Python will not notice that as a Python module. I hope I am clear with that. Yeah, next, I guess. There are TDD techniques that you can actually use. So you can actually fake it. I'm not sure exactly the topic on this one, but essentially you can actually have mock stuff if you are testing bigger parts of a program and then you don't want to actually include all of them. You want to pinpoint and test a specific thing. So for that, what you can do is you can use mock testing that allows you to actually essentially fake it, right? And then also you can actually use test lists. I think this refers to parameterized testing. This is where you can actually make a lot of tests that follow inside something that looks like a list, essentially, right? Um, Fake it. Okay, there's a description for this ISO. Faking is a technique where we hard code the values to get the test to fail, to get a test to get a test to fail, then we replace the hard-coded values with the other hard-coded values to make the test pass. I'm not sure if this makes sense to everyone. Right. I think I'm just gonna read it again. Okay, Amo?
So there's a question on YouTube. Someone is asking if the LMS bot grades you on having good tests.
Okay, that is an interesting question. I would like to answer this way first. First thing is think about yourself, right? This actually benefits you better. I think I've been telling my mentees a lot of the time that if you write better tests, it actually takes a shorter amount of time for you to actually write the program that works, right? Compared to when you are not guided by tests, right? So if you write actual good tests, it allows you to have good quality work that you are submitting, right? So essentially on the LMS, of course, half the time there are also some tests on the LMS site that actually test your code for correctness. I think that's where the grading actually comes from. But also for you to actually speed up your coding process, just make sure you write tests that are really good so that they can actually even challenge you, write edge cases and all those other things. But sometimes doing too much can be, can be, it can actually lead you to moving backwards. But write as much tests as you want. Make sure they test as effective as possible. Also, do not be afraid to be wrong when it comes to testing. Sometimes do criticize your test. If maybe you would find that they're actually wrong, they're not really testing the functionality, do not be afraid to also change them to something that's actually okay, right. Finally, we replace the hard-coded values with our actual code without breaking the test, right? So essentially, I would say we would have this anxiety after writing test where we feel like this tests actually don't want me, they don't like me or something like that. So essentially, that would be you not trusting whether or not the testing interface tests correctly. So what you can do for actually doing that is you can actually fake the return values inside of your functions. And then when you fake those return values, meaning hard code them essentially, right? So when you fake those return values, what it will do is you can see if you faked a return value and then the test is not passing, then you probably made a mistake when writing the test, right? But if it actually passes, then you know you can actually move on and replace the hard coded values with actual code without breaking the test, essentially. Does that make sense? I think. Okay. Musa, you can talk.
Okay, can you hear me?
Yes. Can you?
Okay,
I think your volume is okay. Sure, you can talk.
okay. My question is, can we go back to the Danda init file?
Okay. Sure.
Yeah, I wanted to ask, what if you have a folder for test only, and then you have a folder for your main code? So
Yes.
how would you incorporate that init thing inside your code, inside those
Okay.
folders?
Okay. So essentially, when you have a different file, this is where the Danda actually has to be included. But if everything is in the root like this, you won't necessarily have to have a Danda in .py. So as I said, what the Danda init.py does is it makes sure Python knows your test directory is a Python module. Essentially, that means that there are Python files in there that it can actually go and look for. Right. I don't know if I make sense. If I also answered your question with that.
Yes, you did. I also have another one.
Okay.
What if you want to test files that are in a different folder, but then they're under the same root directory? Is
Um,
that
if
possible?
you
Can you?
anything is possible, my brother. But what are you saying? If you want to test
Oh, I'm
something
asking.
in
Yes,
a
let's
different
say I
file.
have a folder for, yeah, folder only for test files, and then I want to test something that is in a different directory, but all of them, they are under the same folder,
Okay.
but in separate folders. So there's the main file, with the main functions, and then there's another folder which has testing files.
Okay. So I think I will have to show you guys the way you are supposed to actually structure this properly, because I don't know if they made a mistake on these things, but essentially what test incrementer.py and init.py represent is something that's inside of a separate folder, which is normally your tests folder. That's where you normally put your tests, right? And then init.py would be there for the purpose that I just mentioned, right? And then incrementer.py would be left in the root, right? So the way you would be able to reference this, I think if you just make it a Python module, it will be able to determine where this is. I don't know if I make sense with this. So with your import, because remember the methods are inside of a different test class. So you're going to import the methods from that class. I don't know if I make sense. I think. Okay, sure. Um, sure. So yeah, continuing on the fake it and test lists. So I think we were done with the fake it part. So also there's test lists. When you're starting a programming cycle, make a list of the tests that you need. You you need. Yeah. Okay, I apologize for this. When you start programming cycle, make a list. Essentially just make a list of the tests you think you will need, right, for that, right? So write it down in any order. Do not try to be as do not try to be the neatest there, right? Then pick one test. Often it is the test that is least scary to write. So half the time it's really hard to actually know how you're going to test something, and this is something that actually happens to everyone. Don't be scared. But just try to start small every time and then incrementally go to the harder tests, the harder things to test, right? And then also try to write the test and get it to pass. If you can't get it to pass, leave it and pick another. Once you complete the test, strike off irrelevant tests and add on new tests, right? So irrelevant tests would be maybe you were testing for something that maybe you are still learning about the problem that you are solving, and then you feel like at some point when you continue you see like, okay, I didn't actually need to test for this, right? So it is, as I said, do not be afraid to remove stuff on your code, right? So at that point you can actually remove those parts, right? So we're going to be having a demo, which is your like I really don't know how to do FizzBuzz, eh? But I have you guys to help me out with this. So we're going to have a demo with FizzBuzz. I don't know if Ngabentle is here to take over. Ngabentle, are you with us? Does anyone know when Ngabentle is? Okay, I'll just go through the slides for it, and then he will come and demo the actual um coding part of everything, right? So FizzBuzz is a counting game. I think you guys know it from bootcamp. Maybe even if you visited things like HackerRank and all that other stuff, you would have seen FizzBuzz. So yeah, so let's continue. So here's our test list. So essentially, now we'll be showing you how you can actually make your own test list, because I think it's proper to be guided by example. Okay, Ngabendle, but I'll just go through this part now. Okay. So essentially to make a test list, it would look something like this. You know that if the number is divisible by 3, then we're going to replace it with fizz. And then let's continue. If the number is divisible by 5, we're going to replace it with buzz. But then now, if the number is divisible by 3 and 5, we can replace it with fizz buzz, right? And then the last one, if it is any other number, then it is that number, right? So this is how you can actually make a test list, right? So my advice from this, I think this looks nice, and what I would advise for going forward is maybe include this in your pseudocode. When you write pseudocode, just make sure that, okay, I'm coming. Make sure that you can actually reference your expected results and write them out in this way. As you can see, it's not exact code yet. It's just pure and plain English where you're describing your expectations of the program, right? And then, yeah, so this will be, the fact that not all of this is implemented is, but it's fine. But your turn would be doing this for Are we supposed to send this to them?
Yeah, we're gonna send it
Okay.
email.
Okay. 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 It's fine. So you're going to be doing something, an exercise, as I said, guys. So essentially, it's going to be for reversing a word. So essentially, you're going to do everything from writing a test list. We'll be on the ground. I'm coming on the ground now. I don't know where the thing that we're supposed to do
This way.
practically is.
Yeah. It's supposed to be now, but they're supposed to have their mentors helping them.
Yes. Okay. Okay. So essentially you're going to be writing on reverse a string. So you're going to be writing um I'd like you guys to start with the pseudocoding part of it, pseudocode for how you can actually reverse a string. And then you're going to be writing a test list part for the whole thing. I hope you guys took notes. And then after writing that, you're going to be implementing the test classes for it. And then afterwards, maybe even writing the code for that. So we are coming on the ground to see you guys for that. Right. And then I think it will be announced when we have to return to the call. Sure. Amo, you had a question, sorry.
So someone is asking, how would you test the methods of a class?
The methods of a class. You create an instance of the class, and then you call the methods on the instance, or you make your methods static. It's one of the two. But you guys don't have to stress about this. But just create an instance essentially. Is that fine? The person can actually talk on the chat so we can hear if they are answered. Do you have anything else to say on that? Okay, let me try to open this myself now. Is it okay? Let me see. Okay. Sorry for asking this late, but do we use a class for our tests only because we have to inherit for unit test, or is there another reason we may not have learned about? I think for unit testing, I've always seen the implementation in using a class. Is there a different way?
Okay, it's only because you have to inherit.
Okay. Yes.
Okay. The reason you use a class is because you have to, as this person did say, you have to inherit from unit test. And when you're inheriting a class. And so that's the only way for you to do it. But there are other methods if you're using other libraries or frameworks that allow you to write tests without using classes. I hope that answers your question.
Okay, but they did answer also in here. I think that can answering. Yeah, okay.
Yeah.
That's all the questions.
Yeah.
So
Okay.
tell them we're going.
Okay, we will come to the floor right now to help you with the project to reverse the string.
Okay.
Okay.
Yeah, bro. It's my baby type.
Guys, I just want to announce that I have sent the starter code to your emails. So if you just open your emails, you're gonna find the starter code. So just use that. It's a zip file. Just unzip it and work on that. Just an update. There was a problem with the file I sent before, but I've just resent it. It should work now. So
Okay, guys. I hope you can hear me. For those that are in the call, but I think you will just spread the message toward everyone else. So what you guys are gonna do now is you're going to finish up. Mentors on the floor are going to make sure that you guys finish up with this, and then when you are done, you can actually go home. But the other thing that will happen is your mentors are going to look for you guys to actually send them your projects. And then you should send everything essentially from pseudocode. Your pseudocode could be comments, could be a TXT file, could be a written paper if you send them an image. And then I think just to make it all fair for everyone who is participating, the mentors will also have to write a review on you on the mentor portal, where they're going to say this is how you did for the workshop practice work. So just make sure you do your stuff so that you don't get a bad review essentially. If there are any extra questions, I'm available to answer them. I'm on the floor. Yeah.
Sorry, Smiley. So please can you please repeat yourself?
Can I repeat myself? Is that what you're saying?
Yes, please. What is
Okay. That's gonna make a lot of noise. Okay. So what I was saying is you guys continue working at least until 35 past. And then when you are done with that, just make sure you send everything to your mentor. I don't know how you're going to choose to send it. I think maybe even probably by email. And then what your mentor is supposed to do from there is they're supposed to write a review on the mentor portal for you. That will actually where they are going to actually explain how you actually did in this project and whether or not there was even participation from your side, right? So just make sure it is in your duty to make sure you actually send the things out. Is that clear?
Thank you so much.
Okay.
Cool.
Yeah, I
Cheers,
think
guys. Thank you so much.
okay. Thank you, Peter.
Cheers. So the session is recorded, guys. It's on YouTube. That same YouTube link that I shared. You can access it if you feel like you missed any information. Otherwise,
Uh, okay, Peter, just to confirm, it's okay if we write the reviews on the portal, right?
yeah, it's okay.
Yeah. Thank you.
Cheers, guys.